can as well see my screen and we can start with the webinar. To start with the webinar, some words about myself, the presenter for today. My name is Daniel Seibold. I'm a researcher at the Ulm University in Germany, and in CloudSocket I'm responsible for the BPaaS deployment part, so namely the Cloudiator and the Cloud Provider Engine, which we will see later on. Some technical details about today's webinar. All microphones are muted, so if you get any questions or any questions will pop up during the talk or afterwards, just type them into the chat and I will answer them at the end of the webinar. For today's webinar, the agenda comprises the following points. First, a brief overview of the CloudSocket project. What is it about? What are the goals of the CloudSocket project? And in which context is the BPaaS deployment in the CloudSocket project? The second point will be the BPaaS bundle deployment, which steps comprise this deployment. The third step will be the Cloudiator framework. What is the Cloudiator framework? How is it used in CloudSocket, and what are the capabilities of this framework? The fourth point will be a demonstration of an actual BPaaS bundle deployment, so a live demo, concluding with a summary and outlook to the next and upcoming webinars and open topics. And in the end, I will hopefully answer all your questions. So to start with, the CloudSocket project. What is the CloudSocket project? Therefore, we will have a short look at the CloudSocket webpage, which is released in a new design recently. So here you can see the CloudSocket project basically translates and wraps business processes into specific technical solutions, so-called BPaaS bundles, which are available and executable in the cloud. So the main target group of CloudSocket are small and medium enterprises, which have not yet defined their business processes, or which are looking for some predefined business processes and want them just with a one-click buy and execution to have them ready to use in the cloud. Therefore, CloudSocket provides several steps. Well, it provides support for the design of completely new business processes and the respective workflows. It provides support for the allocation of actual cloud services to these workflows to make them executable in the cloud. It provides as well a marketplace of predefined business process as a services bundles, which can be deployed, which we will see later on, by one click and are ready to be executed by the SME. Then it provides support for the execution of these BPaaS bundles in the cloud. And as monitoring and feedback loop, there is as well support for the evaluation of running business processes in the cloud in order to enhance existing business BPaaS bundles and to improve them with new releases. This is one of the target groups of CloudSocket, and there are as well the target group for the BPM experts, the so-called brokers. Brokers can use the CloudSocket platform to define new business process as a service bundles and offer them in the marketplace to the SMEs, which then can buy these bundles and execute them. All this will be shown later on, partially in this webinar, and we have, of course, already some demonstration videos up on the webpage and as well on the CloudSocket YouTube channel, where you can see all these steps in more detail, as this webinar is about the BPaaS bundle deployment. So coming back to the CloudSocket project, to the more technical view on the project, let's have a look at the architecture. Here you can see that CloudSocket comprises 4 environments: the BPaaS design environment, the BPaaS allocation environment, the BPaaS execution environment, and the BPaaS evaluation environment. The BPaaS design environment basically enacts the definition of a business process, its transformation into an executable workflow by applying semantic enrichment, and in the end there will be a design package comprising the business process, the workflow, some additional high-level deployment rules, KPIs, and semantics, which is then passed to the allocation environment. In the allocation environment, there will be this high-level business process and workflow enriched with the actual cloud services. So which cloud provider to use, which service to use, which service to put on which cloud provider, together with some additional information about monitoring, adaptation, and KPIs. This BPaaS bundle is afterwards sent to the execution environment, which will take place the deployment in the cloud to provide ready-to-use cloud services to execute the BPaaS bundle. The evaluation environment will monitor the whole business BPaaS bundle execution, analyze it, and feedback the derived information to the BPaaS design environment to allow enhanced BPaaS bundles, or to improve the BPaaS bundles for further use. Well, that's a rather high-level view on the architecture. Today, the focus relies on the execution environment and mainly on these 3 parts: the BPaaS bundle, the BPaaS marketplace, but mainly on the cloud provider engine where the Cloudiator framework relies. If you're interested in the other environments, then please have a look at our YouTube channel or at the webpage. There you will find additional webinars explaining how the BPaaS design environment and allocation environment will work in detail. And as well, for the evaluation environment, there is an upcoming webinar in the near future. So let's have a very high level, or still a high level view on the deployment of a BPaaS bundle. Which steps are required to deploy such a bundle? Well, let's assume we got an SME which needs a business process which is available at the CloudSocket marketplace. So he can have a look at the marketplace, select an appropriate bundle, which is then which can be purchased. In case of a purchase, the BPaaS bundle will be sent to the execution environment as first step to the cloud provider engine, which is in the following always named the Cloudiator framework. And the Cloudiator framework will then take the necessary information out of the BPaaS bundle, especially the information with respect to the cloud providers, and prepare all the required services in the cloud. So, for example, spawn a virtual machine on OpenStack or Amazon, or prepare the environment on the platform as a service providers such as Heroku or OpenShift. After all the required components are deployed on these services, the end user will be able to execute the BPaaS bundle by exploiting the recently deployed cloud services. Well, that's still a very high-level view on this execution. We will later on see how it works in detail and in a live demo. Just as already said, the BPaaS bundle is an important part of this deployment process. So I will briefly explain what is comprised in the BPaaS bundle. There are mainly 6 different models or templates inside. First, the design package comprises business process model, workflow model, KPI and DMN model, some marketplace metadata about the pricing and categories and so on, a deployment plan, some service level agreements, some adaptation rules which are optional, and some technical KPIs for setting up monitoring, setting up the monitoring of the BPaaS bundle. For today's webinar, the important parts are the deployment plan as the most important part, and I will just briefly mention as well the service level agreements, adaptation rules, and technical KPIs. Well, the deployment plan comprises a model, namely the CAML model with a nice logo which you can see above. CAML stands for the Cloud Application Modeling and Execution Language. It comprises a complete model of applications in the cloud. So the cloud provider specific details, for example, what kind of virtual machine flavor, what kind of image, what kind of location is required, then some software component specific details like what are the communications between multiple components, what are the required lifecycle actions to set up this component, and as well what kind of the monitoring information is as well covered in the CAML model. So what kind of monitoring data can be acquired by this software component, and as well adaptation rules can be specified in the CAML. And this deployment plan will be used by the Cloudiator framework and translated to the respective calls to the cloud provider APIs to actually deploy the virtual machines and software components on the virtual machines. The CAML is comprehensive, but as well it's a rather complex model. That's why I won't go into any details about or any further details about the CAML in this webinar, but in case you're interested how such a cloud model looks like, please have a look at a previous webinar with the title BPaaS Adaptive Provisioning via CAML, where you will find a very detailed explanation. What is CAML? What is it capable of? How can you define a CAML model? And there is as well a webpage about CAML where you can have a look at and find some documentation, some examples, and additional information. Now, let's come to the Cloudiator framework and let's see how it is exploited in CloudSocket and what are its actual capabilities. The Cloudiator framework is developed by the Ulm University. It is completely open source, available on GitHub under the Apache 2 license. There are as well many documentations, some additional videos and some examples, and as well some publications explaining what Cloudiator is doing. I will give you now a brief overview of its capabilities and how it is used in CloudSocket. So Cloudiator is a so-called cloud orchestration tool. It automates the application management in the cloud by managing the full application lifecycle of applications in the cloud, meaning the provisioning of resources, the deployment of the software components in the cloud, and as well the wiring of the software components together, in addition with some monitoring and adaptation features, and as well as some more features which will be shown in next slides. Cloudiator enables the abstraction of cloud provider specific details. So the user of Cloudiator doesn't have to care about some details of Amazon or Azure or Google Compute. That's all abstracted by Cloudiator and by providing a unified API. As already said, it provides some monitoring and adaptation capabilities and some related tools which you might heard of are Apache Brooklyn and Cloudify, which basically operate on a different kind of models, namely the Tosca model. And again, you can have a look at the CloudSocket deliverables, where you can as well find a comparison of Cloudiator in respect to Brooklyn and Cloudify. So coming to the features of Cloudiator, there are basically 6 main features available. The multi-cloud feature, which means Cloudiator is able to orchestrate applications across different cloud providers by providing a unified API to the user, so the user doesn't have to care about the technical details. This comprises infrastructure as a service provider as well as platform as a service providers. Then there is the cross-cloud deployment feature, which means Cloudiator can deploy applications or distributed applications across multiple cloud providers. So for example, deploying a database on OpenStack and deploying the application server on a different cloud, for example Amazon. And again, that's as well possible across multiple cloud provider levels. So deploying, for example, the application server on a PaaS and the database on an IaaS. It supports the automated discovery of cloud provider offerings. So this means Cloudiator is capable of discovering all the available images, all the available hardware flavors and locations which for one specific cloud and one specific user at this cloud. Because with different user roles, you can get different kind of images and hardware flavors. Then there are as well monitoring and adaptation capabilities. So monitoring the system usage or application-specific metrics of a deployed application, scaling a deployed application. And there is native Docker support in Cloudiator. So applications are usually deployed inside a Docker container. to ensure if multiple locations are multiple software components are deployed on one virtual machine. Each is Dockered in one container to ensure that there is no interference between these applications. This is basically the feature set of Cloudiator. Now just one example explaining the cross-cloud. So here we have now again the example where we have a load balancer which might be deployed on Google Compute platform. Then we have an application server which is deployed on Heroku on a PaaS provider, and we have the database which is deployed on a private OpenStack instance, maybe for some privacy reasons because of the data. And all these different kinds of cloud providers are abstracted by Cloudiator and offered via a unified API. So now let's have a look at the deployment steps. As already said, the BPaaS bundle contains a camel model, which comprises the required information or packed into a model. So there are separate models for the load balancer, for the application server, and for the database, and each of them represents a software component, and each software component has its own install, configure, start, stop life cycles to which handle the actual setup of the software components on the respective hardware or environment in case of a platform as a service. So if the application is deployed on IaaS, then a lifecycle agent, namely Lance, will take care of the setup and the wiring of all these applications on the virtual machine. If the application software component gets deployed on a platform as a service, the PaaS unified library, which is developed by Atos, as well a partner in CloudSocket, will take care of providing the environment. So for example, Tomcat 7 to deploy a VAR application, then it will be handled by this component. But it's all encapsulated in the Cloudiator tool. Now a short overview of the discovery feature of Cloudiator. What does this mean now in detail? Again, let's assume, well, the discovery is currently only supported for the infrastructure as a service level. For the past, this might be developed for the future. On the infrastructure level, there are typically offered virtual machines, but these virtual machines might be or are definitely differently described on each cloud provider. That's why Cloudiator is able to gather all these information for the respective cloud provider and bring them in a unified format, which allows to map the model from the camel to the respective offerings of each infrastructure as a service cloud provider. This was the explanation to the features. Now I will show briefly an overview of the Cloudiator architecture, which is split in a home domain. The home domain is basically where the Cloudiator framework runs. So this can be run locally or can be deployed in the cloud. There are the different components, so a REST API to interact with the user or with directly or with a client via programmatically. Then there's a deployment engine, some registries to store the cloud provider offerings, the discovery agent storing the data there. Then there's a recovery engine in case to overcome some failures during the deployment, the sort abstraction layer, and then there's as well a time series database to store the monitoring data, and a scaling engine and some aggregators to evaluate the monitoring data and scale the application if there are some scaling actions defined. The second part of the Cloudiator is the remote domain. So on each virtual machine there will be the lifecycle agent Lens, which spawns the respective the containers for the respective software components. Then there is a monitoring agent pushing data to a lightweight local time series database where data is pre-aggregated and afterwards sent to the home domain of Cloudiator. And on the remote domain, this is basically represents the virtual machine with the containers on these virtual machines and where the actual software components rely on. In case if you're interested in more technical details about the Cloudiator, you can have a look at the Cloudiator webpage. There's as well a detailed webinar by my colleague explaining how Cloudiator works in more detail. Now the next step, or now comes the interesting part, the demo. For the demo scenario, we picked for today the send invoice BPaaS, which is exploited by the Golden Worm startup. What is the Golden Worm startup, or what is the send invoice BPaaS? Therefore, we can have another look at the webpage. So the scenario is rather simple. We got a startup with the name Golden Worm, where Susan, a biologist, is searching for an efficient way to send invoices. She basically needs two kind of services: a customer relationship management and some service which creates and sends invoices. This is implemented for this BPaaS bundle by the Invoice Ninja. Invoice Ninja is an open source available software which is exactly creating invoices and sending them to customers. Now, how can Susan find this and deploy this BPaaS bundle? Therefore, we will have a look at the CloudSocket marketplace. So this is the CloudSocket marketplace. It's publicly accessible, so if you're interested, feel free to have a look at it and browse through the bundles. Here you can see a lot of available BPaaS bundles, which are partially executable. This is shown by the add to cart. In case there is so far only the business process and an abstract workflow available, you can press the I want it button and CloudSocket will get notified that there is interest in this bundle, and the brokers will implement fully executable BPaaS bundles. For today's demo, we will use the send invoice on an infrastructure as a service. We can have a look at the bundle. Here you can find some basic explanation. CRM is used, which is used as a software as a service, and an Invoice Ninja is used for the invoicing, which will be deployed on an infrastructure as a service. Well, we got a business process, we got a workflow file with all the executable steps, and we have some SLAs described for this bundle. Now, in order to buy the bundle, you need an account. So I will log in with my account, prove it, and now I'm able to add it to the cart. And now I can proceed to the checkout. I have to pay with the PayPal account. So and after the payment transaction is finished, the BPaaS bundle will be, or the deployment of the BPaaS bundle will be started. So let's wait. So now we got the notification that the BPaaS bundle was successfully registered. The deployment has started, and as soon as the bundle is hopefully successful deployed, we will get an email with the link to the execution of the actual deployed bundle. As this will take some time because now the virtual machine gets spawned up, the software component needs to be installed and so on, I will switch back to the presentation and show you now on a technical level what is happening behind the scenes and what is Cloudiator currently doing. So as we've already seen, the user entered the marketplace, checked the available bundles, found a bundle, and deployed or purchased the BPaaS bundle in the marketplace, which triggered the BPaaS bundle deployment. The bundle is sent now to the execution environment, and the first or the receiving part of the execution environment is the cloud provider engine, the Cloudiator framework. The Cloudiator framework is now translating the camel file into the required calls against the cloud provider APIs. For this deployment or for this bundle, there was an OpenStack instance defined, an OpenStack infrastructure as a service, which is running at the infrastructure of the Ulm University. And now the first step is that Cloudiator will create the virtual machines on this infrastructure. For this bundle, there is, or for this software component, there is only one virtual machine required, and the specifications, which image to use and so on, and which hardware flavor is defined in the camel file, and is now or is currently processed by Cloudiator. So we can have a look at the dashboard of the OpenStack instance to see if there is a new virtual machine spawned and if everything works so far. So we can have a look at the instances, and here we see there is a virtual machine which was currently spawned on an Ubuntu server, already a public IP available with a small flavor. So now the Cloudiator has already set up the virtual machine, and the next steps are currently executed. So currently all the required software for installing the Invoice Ninja is set up. So the lifecycle engine is installed on the virtual machine, the Docker containers are spawned, and the required dependencies for the Invoice Ninja. So for example, the Apache web server and some additional third-party dependencies are installed on this virtual machine. After the software component is installed on the virtual machine, there will be as well set up the monitoring in step 4. So in the camel, there's as well defined the monitoring sensors. So for this BPaaS bundle, there's defined that the system The CPU usage and the memory usage of the virtual machine is monitored. This is now automatically configured by the cloud provider engine, and the respective monitoring agent will report the monitoring data to the monitoring engine, where the monitoring data can be accessed, processed, and used for further actions like adaptations and so on. But this will not be part of the today's webinar, because for these steps there will be as well dedicated webinars upcoming. So the next step will be the SLA engine will be notified after the deployment is finished. So the SLA templates, which are as well included in the BPaaS bundle, are sent to the SLA engine, and again for the SLA engine there will be a dedicated webinar which is upcoming. So no further details on this in this webinar. In the meanwhile, we can have a look what is the current state of the deployment. So we can have a look at the UI of the cloud provider end or of Cloudiator to see if the deployment is ongoing. So we see here that we have two applications. So basically there will be two bundles. One is already installed, one is still processing. So this was the one triggered beforehand. So there's still, which means there's still the deployment ongoing. And with the when the deployment is finished, the step 6 will be applied, where the workflow file, which is already defined in the BPaaS bundle, will be updated and sent to the workflow engine. So the workflow file will be enriched with the actual endpoints of the deployed services, because they're obviously not known beforehand, and registered at the workflow engine to allow the user to later on to execute the BPaaS bundle via the workflow engine. As soon as the registration at the workflow engine is done, the workflow engine is capable of communicating with the recently deployed Invoice Ninja, and as well with the CRM system, where the Microsoft Dynamics CRM is used for this bundle. And well, as the Microsoft Dynamics CRM is provided as a software as a service, Cloudiator will not interact with this kind of service, because as software as a service does not allow any kind of orchestration features. This is decoupled from the Cloudiator and already predefined in the workflow file. And now the workflow engine is basically ready to execute both or to interact with both services, which to execute all the workflow steps in the defined sending invoice workflow. After this step, the deployment is basically finished, which means the cloud provider engine will, in step 8, inform the marketplace that the deployment has finished. The marketplace will then notify the user by sending an email that the deployment was successful and where the user can access the deployed BPaaS bundle. This is then done via the workflow engine, because the workflow engine is, after a successful deployment, the central entry point for the end user, where the end user can access the workflow engine and execute the sending invoice business BPaaS bundle. Now we can have a look how such an email looks like. Well, there should already be one. You can see that we got an email by the marketplace that the instant invoice was already successfully deployed. We can open the link and we will be brought to the workflow engine, where we will see under processes there are several processes, and we have currently deployed the send invoice EAS test to Metrics, which is now ready to be executed by using this recently deployed services in the cloud. Now the execution of the actual BPaaS bundle is again a topic of another webinar, which you can have a look at the YouTube channel, or you can have as well a look at the webpage again, because here you will find as well a demo video explaining now exactly how these sending invoices bundle can now be executed by using these cloud services. So for any further information about the execution of this bundle, you can have a look here, or at the YouTube channel of CloudSocket, where you can again find a webinar about this topic. Well, this was basically the demo of such a BPaaS bundle deployment, and this brings me to summary and outlook. Cloudiator, inside the CloudSocket project, it enables the BPaaS bundle deployment by supporting the application orchestration on EAS and PaaS, which means in case the application comprises multiple software components, so for example multiple databases or multiple application servers, Cloudiator will take care of all these deployments, and as well defining the correct deployment order. So first deploying the databases and afterwards the application servers and then the load balancers and so on, wiring these together. If you're interested in more complex deployments, you can have a look at the CloudSocket YouTube channel, where we showcase as well more complex deployments, and as well on the Cloudiator webpage, where you can find again additional or more complex deployments. Cloudiator supports the major EAS providers like Amazon, Google Compute, OpenStack, and as well the major PaaS providers, for example OpenShift, Heroku, Cloud Foundry. As already mentioned during the webinar, Cloudiator provides as well capabilities for BPaaS monitoring and adaptation. Therefore, we have two dedicated webinars which are upcoming: the cross-cloud BPaaS monitoring on the 6th of September, and in the follow-up, a BPaaS adaptation webinar on the 4th of October. So if you're interested in the monitoring and adaptation capabilities, feel free to register as well for these webinars. In addition, as already mentioned, there are already 6 or 7 webinars available explaining the other environments like the design and allocation environments and how such a BPaaS bundle is created from a high-level business process to such an executable bundle in the cloud. The next upcoming webinar will be on the BPaaS SLA engine, which will be on the 5th of July. So feel free to register there as well. And this brings me to the end of today's webinar. Thank you all for your attention. And now I'm happy to answer questions. So feel free to ask in the chat. So currently I don't see any questions. In that case, in case there won't pop up any now, thanks again for your attention and hope to see you in one of the next webinars of CloudSocket. Okay, now there is a question. I will just repeat it for everyone. Can a user register at the execution environment like private OpenStack setups in the marketplace? Yeah, that is possible. There can be specified any kind of OpenStack, but this is defined in the camel file. So during the allocation process or in the allocation environment, when creating the BPaaS bundle, there need to be put the endpoint of the private OpenStack setup and as well the credentials, and then the BPaaS bundle can be as well deployed on this infrastructure. And the same applies for any of the other cloud providers. So it can be as well registered Amazon or Google Compute and any kind of private OpenStack. So any additional question? Okay, seems that was all. So thanks again for your attention and see you during one of the next CloudSocket webinars. Bye-bye.